Road trip. Jorge is traveling 2,563 miles from New York City to San Francisco by car. His next stop for gas will be when the ratio of the distance he has already traveled to the distance he still has to travel is 2 to 5. How far has Jorge traveled the next time he stops for gas? The first thing we're going to want to do is underline key pieces of information in our word problem. So the ratio of the distance he has already traveled to the distance he has still to travel is 2 to 5. So that tells us that this is a part-to-part relationship. So we can identify M and N from our ratio. We also know that he's starting in New York City. Whenever we start a road trip, we haven't traveled any distance at all. So the starting point we usually label as 0. He's traveling to San Francisco, which is 2,563 miles away. So our x1 is 0 and our x2 is 2,563. So now we're going to use the section formula to determine how far Jorge will have traveled when he stops for gas. So we're going to substitute 2 for M, 5 for N, 0 for x1, and 2,563 for x2. When we simplify, we get 5 times 0 is 0. 2 times 2,563 is 5,126. And then in the denominator, we have 7. If we add 0 and 5,126, we end up with 5,126. So then we would divide 5,126 and 7. When we do that, we get an answer of 732.3 miles approximately, we're rounding to the nearest tenth, that Jorge has traveled from New York City, so that the ratio of the distance he has traveled to the distance he still has left to travel is 2 to 5. In all of the previous examples, we have had a part-to-part relationship. It looks like this. Find P on line segment AF such that the ratio of AP to PF is 1 to 3. When we have a part-to-part relationship, it is easy to identify M and N. They are given to us in the ratio. However, there is another type of way to partition a line segment, and it's called a part-to-whole relationship. This is what it looks like mathematically and in words. Find point P on AF such that the ratio of AP to AF is 1 to 6. Notice that unlike in our part-to-part, where we have the point that we're looking for in both segments, we only have it in the first one. This is what kind of clues us in to the fact that this is a part-to-whole relationship. And because this is a part-to-whole, this second number, 6, is representing the total number of equal parts the line segment is broken up into. It is, in fact, M plus N. So in order to identify N so that we can plug it into our section formula, we need to take the second number here and subtract M. So that's how we get N equals 5 in that first example. This is what it looks like in words. The ratio of the distance traveled to the total distance is 2 to 10. Again, because this second number is to the total distance, it's a part-to-whole relationship, so we have to subtract the first number in our ratio to find N. So 10 minus 2 is 8, N is 8. Another way that can be used to describe a part-to-whole relationship is find point P on AF such that P is 1/4 of the total distance from A to F. Again, This is a part to whole relationship, so m is 1, the top number or the numerator of our fraction, and n is 3. You have to take the denominator of our fraction and subtract the numerator in order to find n. Find b on line segment AC such that the ratio of AB to AC is 1 to 4. So here we notice that we're looking for point B and we only see point B in that first segment. So that means this is a part to whole relationship. M is 1 and n is 4 minus 1 or 3. X1 is negative 5 because that is the value of point A. X2 is 7 because that is the value of point C. So now that we have all of the information, we're going to substitute these into the section formula. So M is 1, N is 3, X1 is negative 5, and X2 is 7. When we substitute those values in, we're going to multiply 3 and negative 5, which gives us negative 15, 1 and 7, which gives us 7, and in the denominator, 1 plus 3 is 4. Negative 15 plus 7 is negative 8, and negative 8 divided by 4 is negative 2. So point B is located at negative 2 on the number line. In mathematics, we're often working with line segments that are on the coordinate plane. So here is how you find a point that partitions a line segment that is on the coordinate plane. If A has coordinates x1, y1, and C has coordinates x2, y2, then a point B that partitions the line segment in a ratio of m to n has coordinates b, n times x1 plus m times x2, all of that divided by m plus n, and then n times the quantity y1 plus m times the quantity y2 divided by m plus n, where m does not equal negative n. Find C on line segment AB such that the ratio of AC to CB is 1 to 2. So again, this is a part-to-part relationship, and M is 1 and N is 2. X1 comes from the point A, so it's the x coordinate of point A, which is negative 5. Y1 comes from the y coordinate of point A, which is negative 2. 6 is the x coordinate of point B, so that represents x2. 2 is the y coordinate of point B, so that represents y2. Now we'll use the section formula to determine the coordinates of point C. So when we substitute our values for n, m, x1, x2, y1, y2, we end up with point C being located at negative 4/3, comma, negative 2/3. Here is a check. Students, please complete the check. Teachers, please pause the video now. So in this example, it is a part-to-part with M being 3 and N being 7. X1 is negative 15. Y1 is 2. X1 is 25. And Y1 is 17. Did you guys come up with the correct answer of C for the point that is the distance he has traveled to the distance he has left to travel, breaks it up in a ratio of 3 to 7. This is the exit ticket. Students, please complete the exit ticket and turn it in before you leave. Teachers, please pause the video.